Okay, I guess everybody can see the screen right now, right? So today, in this lecture, we're going to jump into a new field or a new subsection in the statistic literature. And in the previous course, we have seen the different ways to describe our data set. We have seen that we can use numerical summaries such as the mean, median, and also something like our shape characteristic and our spread characteristics to describe our data set. And also, um, and also we also learned how to use some graphical information to present our ideas. Like we learn box plots, we learn histogram. So basically, these two topics, they are located in our, I guess, the last procedure, which is interpreting our data set. Maybe you guys have a question that how did we recruit those data sets and what is the previous step looks like? So in the previous step, it's about collecting data set. And definitely there's a lot of way to collect the data. But today we are going to look at in a very scientific reasoning of collecting data, which is called sampling. So, oops, there's some question for today. So the okay, so this lecture is not going to appear in the midterm one. So the midterm one is just the first three lectures. Okay, so I would like to start today's lecture with a very hot topic very recently. So I guess everybody knows that in November 4th, there is a big thing happen in United States, which is the presidential election. And I think that's very important in a sense that especially for the citizens in the United States, it could influence what will happen in the following 4 years. And maybe you guys not care about it too much, but I'm pretty sure for the United States citizens, they really care about it. And they are so care about it that they not only they are not only collect the information in the final election, actually right before the election, they are keep collecting the information about what will happen or what the result will be in the election. So this type of the information is called polling. It's basically like an estimation, or you could say it's a guess of who will have more probability or have more chance to win. So you might wondering how we got information from this polling. And here I would like to emphasize that for polling, of course, we cannot collect information from all of the individuals because definitely we cannot uh, do the election every day, right? Because that is so expensive and there is a timing issue that is not allowed us to do that. So instead, we are doing the sampling to sampling our results. However, if you look at 4 years before, which is 2016, and if you look at the same polling results, you will see that we have 70% chance for the Hillary Clinton to win presidency. However, the Donald Trump only have around 28%. So I guess everybody knows the results and what's happening afterwards. And there's a very interesting question is that how come these results is go against to our original estimation in the polling? And why the results is so surprising? So in fact, there is a very important procedure in the polling that play into this part. And this is exactly today's topic about, which is sampling. So first of all, what is sampling? So sampling is basically a process that we are trying to select a subset of the individuals from the populations that we want to study. So first of all, we do have a population, like a lot of people that we want to collect their opinions about which party they support. And for sampling, we are specifically looking at selecting a subset of these individuals that appear in the populations. This is because it is impossible for us to ask every single person about their opinion before the election because that's so expensive. There's a large population in the United States, so we definitely cannot do that. So the alternative way is to, instead of asking all of them about their opinion, we are trying to take several representatives, and these people will serve as the representative for the other um, individuals that they are not being selected. And we'll just ask the information or collecting data from those representatives. So this procedure is called sampling. So in the following part, I'm going to break this lecture into two halves. And in the first half, I'm going to introduce several very important sampling vocabularies or sampling terminology. And in the second half, we're going to see the different ways to design our sampling scheme. So I guess the most important concepts in the sampling will be the unit. So basically the unit is the smallest sampling object that we discuss in a sampling scheme. It could be an individual person, it could be an item like a machine or something, and it could also be a measurement. Like we are trying to do quiz, like you probably have attempt the quiz for multiple times. Then for each times, it could be a unit. So here, the definition of unit is in fact depends on the context we're talking about. So for the election example, our unit will be each individual because we want to collect what's individual's opinion about their the party that they support. But in some other cases, our unit could be different. For example, if we would like to estimate what's the populations of the cities all over the world. So apparently there's so many cities around the world. I cannot to identify them all. So I would like to do sampling by selecting a subset of the cities around the world. And in these cities, although there's a lot of individual or a lot of people in each city, but in this sampling scheme, our unit will be city itself, even if even if it still can break up into a lot more smaller pieces. So for the unit, sometimes we also call it as the individual or subject, just depends on the context we are talking about. So after discussing the smallest unit, then we are going to look at the largest unit, which is the population. So population is in fact the object that we are trying to learn from. So it is defined as the set of all individuals or all units that we seek to study. So in our polling example, uh, our population will be the entire United States population. Sorry, entire United States citizens, because that's they will get the rights to vote, right? So in this case, I would emphasize that population is a more like a general state. Like when we talk about population, we just say, okay, for our polling example, it's just the United States citizen. We are not talking about other things. So just attention to that, and we're going to get back to it later. So right now we define what is the population when we know that it is the final goal that we are trying to study. But in reality, there's a lot of people we cannot reach, or it's possible for us to contact them. For example, in the polling of the election, what they did is they are trying to collect a long list of the telephone number. And then they just randomly pick several telephone and then trying to dial the telephone numbers to ask their opinions. So that's a typical polling did. But as you can imagine, in the United States, I'm pretty sure there's some people that don't have a cell phone or don't have a telephone. And in that case, there's no way to contact them, right? So in that sense, if we design our sampling by collecting the information through the telephone, then we kind of exclude a part of the populations who don't have the cell phone. And what we include is the population that has the cell phone. So basically, this new um, this new framework we are trying to study is called the sampling frame. So it's defined as the set of all of the units from which we really draw our sample from. And this is decided by our design. So if saying if we are collecting data from say from an online survey, and in that case, our sampling frame will be changing because for online survey, we will only target on the individuals who are able to work on the internet, right? So in that case, the sampling frame is usually determined by our design, and it is also changeable. So although you can see there's a difference between the population and the sample frame, but in reality or in practice, we usually confound these two concepts. So here, I think it's very important to distinguish their difference in their meaning. So for our population, it is usually refers to a more ideal situation. Like in our example, we are trying to look at the United citizens who will has the eligibility to vote, right? So our population is looking at this part. However, for the sampling frame, we are more looking at more reality scenario. So we are considering the techniques issue, and we're also considering the funding that must come into play during our sampling. So we know that we have so many constraints that we cannot study complete cohort of our population. And also the population, like I said, population is more general idea. So like here, we just talk about the population of the citizen. But the sampling frame is more specific. Like we are talking about the specific citizens who has the telephone. So for our sampling frame, it could be a very, very long telephone list. So we are looking at the specific aspect in the sampling concept. And also, as I mentioned, the sampling frame is determined by our sampling design. So if we do it by phone or if we do it by online, our sampling frame will be different. And mostly, the sampling frame will be a subset of the population. This is because the fact that in the population, although ideally we want to study them all, but some individuals are not reachable or we are not able to contact them. So that's why our sampling frame is usually resulted as the subset of the population. So after understand what is our population and we look at what is our sampling frame. But when we're doing polling, we're not really asking every single person's idea or their opinions about which party they're gonna support. And in reality, we're going to ask a subset of them. So this subset, it has another name called sample. So here I would like to emphasize that the sample is specifically refers to the individuals or the units that we are really collect the data from. So for example, there might be some individual that we are trying to contact, or we do dial a phone call to them, but they didn't respond. But for those individual, although we tried to contact them, but we didn't get any information or data from it. So in that case, those individuals or objects cannot be called sample. And for those individuals, there's another name for it, which is the non-responder. So if we study from our beginning, which is the sampling frame, which is the largest thing we are looking at by design. So we can divide our sampling frame into two parts. So the first part contains all of the units that we actually contacted, or we actually dialed the phone call to collect their opinions. And another half will be the uncontacted units. So basically, we didn't even try to contact them because we didn't sample them from our sampling scheme. And for those individuals that we really contacted, we can further divide it into two parts. The first part is the individuals that we really collect the data from. So we know that these individuals are sampled. And for the remaining individuals, that for those who we try to contact, but they didn't respond the answer, and we will have a special name called the non-responder. So far, any question about the concepts for the population, sampling frame, and sample and non-responder? Any question about it? Okay, okay, great. I guess there's no question on that so far. So now I'm going to do group activities. So since now you have understand what is population, what is sampling frame, and what is sample, and what is non-responder, then I'm going to show you a sampling scenario, and then you are going to discuss what is the population in that example and what is the sampling frame. And in this group activity, like before, I'm going to break you into several small rooms, probably in a group of 3 to 4. And you are not, so it's not mandatory for you to participate in that. And if you are not comfortable with that, you can just not accept the link and just stay in the main planetary. So what is the scenario that we are trying to discuss? So the scenario is a more hypothetical, which is not true. I want to emphasize. So in order to evaluate students' understanding for the course, the SS 1023 and 2037, and I set up a pop quiz during the lecture on Tuesday. And among, say, 150 students of the course, there are 100 students really attend the lecture on that day. And finally, I received 80% responses, and the missing responses are due to the accidental unstable internet connections. So for this way, for this example, I'm showing a procedure of how I trying to collect the information from you guys by doing the sampling. Although I didn't purposely do the sampling, but in this case, it is still belongs to follows our sampling scheme. So I would like you to decide which part should corresponding to the population and which part corresponding to the sampling frame. And finally, what is our sample and what is our non-responder? So like before, I'm going to give you 8 minutes to discuss about this. And also you can use probably the first 2 minutes to introduce to each other. Okay, I'm going to break the rules. So you should be able to receive the invitation. And if you don't want to participate, you can just decline that. So I'm going to send this scenario to everyone so that you can bring it to your discussion room. Okay, so there's one student asking to explain non-responder. So, so the non-responder is coming from all of the individuals that we are trying to contact with. So, although we contact some individuals, but not all of them respond our request. Like if we send a survey link to a group of subsets that we're trying to contact with, but for some of them, they didn't reply, and these individuals or this group, they are called non-responder. So that's part of our contacted units. That's usually we distinguish those non-responders with our sample because sample, we really get our information from those individuals. And for non-responder, we didn't get any information, although we contact both of these two groups.
Hi. So I didn't saw the Quizlet, so I didn't hand it in on the Quizlet. So how do we hand it in now?
Oh, you can just send it to me for the assignment, right?
Yeah, on email.
Yeah, by email. You can just
Okay,
send.
sorry about that.
Yeah, that's okay. No worries. Yeah. Is there going to be a quiz or practice question for this lecture? So, because oh, you didn't know that yet, but today's lecture is not coming up with any independent task. So there's no any quiz coming up for today for this week's lecture, but I do provide some practice question for you to do some practice. Yeah. So for the students staying in planetary, probably you can also think about this question, like um, what is the population in this context and what is the sampling frame in this context? Because this is very important. I'm pretty sure you will see a lot of practice question about defining the population given certain context. All right. So I guess everybody is back to the planetary. Um, so will come back. And first, I would like to emphasize this activity is very important in the sense that in today's lecture about the sampling, you will gonna see a lot of similar question, a practice question about identifying uh, each different concepts and in a different scenario. So I guess this is a very typical scenario, and to help you to identify what's the different part of this text, I'm trying to highlight the objects that probably associate with the um, different concepts. So we have the students understanding for the course, and we have 150 students of the course, and 100 students attended the lecture, and 80 responses, and the missing responses. So probably now I will do a polling again um, to recruit your idea, which one you believe is most likely. So now let's first look at the population. So let's define each object as A, B, C, D, E, and then use the use the multiple choice to to response which one or which part you believe should be the population. Oh, we have really diverse. So remember, population is for very general concepts. Like in the United States polling example, the population is just the United States citizen. We are not talking about their telephone. We're not talking about their internet or something like that. So it's a very general case. Okay. Okay. So I guess there's a lot of students believe it's B. So uh, in fact, the population is just the students in our courses. So remember uh, although yes, there are 150 students of the course, but this is a more specific definitions because we are talking about the numbers. But for population, we are more focusing on the general sense. Like we just talk about the students in the SS in these courses. So, oh, there's some student believe they should be the same. Yeah, so actually for this context, these two things are equivalent because in this specific example, our population and the sampling frame are referring to the same group of people or same group of individual. But just like I mentioned in before, the population is more talking about the general sense. Like we just talk about students. We just forget don't just forget about how many students are there. Just talking about the student in this course. So in fact, for this 150 students, it is our sampling frame. So in our sampling frame, it is refers to the biggest cohort that we are trying to collect the information from. So in fact, in this scenario, our sampling frame is the same as our population, which is so as you can see for the sampling frame, we are more looking at the specific item, like well, which is the student in our context. So I guess a lot of students might get it. I guess the sampling frame is very challenging in this scenario because some student might think C could be the sampling frame. So C is the all of the students that attend the lecture. But remember, the sampling frame is the largest group that I'm going to reach by design. So when I design this sampling, did I target on those 100 students uh, because I don't know which student will attend the lecture and which student won't attend the lecture. So by design, I'm not targeting on any specific group of the student. So that's why for the sampling frame, it is the complete list of the students, which is the 150 students. So I guess this is a very tricky part. So in our scenario, which will be our sample? I guess this one will be much simpler. So which part is the sample? So maybe it is helpful to look at the diagram I showed you earlier. So we start from our sampling frame, and then we divide the sampling frame from the units we really contact with and the units that we didn't contact with. And for the units contact with, which is the C here, and there's a portion of the student really responds, and there's another students didn't. So which part should be? Yeah, I think the majority of the student got it right. So the sampling is this 80 students who responds to our quiz. So this is because, so I guess everybody agreed that 100 students attend the lecture is the students really trying to take the quiz, and which is being contacted by me. So there's a question about what would C be in this question. So C should corresponding to, maybe I stop here. Okay, C is actually corresponding to this part, which is the contacted units. So remember, we have 150 students in our sampling frame. That is by design, I'm trying to contact with all of the students in this course. But of course, there are some students really attend the course, and that's the student I really contact with. And there's another group of the student I didn't contact with, right? And for those students, that are students who didn't even attend the course. So yeah, I guess for the sampling, I guess everybody get it right, or most students get it right. So the sample is refers to a subset of our contacted units. So that's why we say the sample will be the 80 students that is really collecting the data. And the non-responder will be the remaining 20 students who has the technical issue where although they are trying to contact us, but we didn't get any information from those students. So we say this student should be the non-responder for our scenario. So I guess the most tricky part for this is to identify what is the sampling frame here. So just keep in mind that when we define the sampling frame, we always look at our design. So what is the group that we are trying to contact with, or the largest group that we are trying to contact with. So it's kind of showing us the boundary that's all of the individuals that could be selected by our design. So to help you better understand what is the sampling frame, here I give another example. Like if I kind of changing the hypothetical scenario by saying, okay, so today's lecture is for 1023 students only, which means we only have 75 students that participated in it. And in this case, our sampling frame will change because before I design the sampling, I know that in this lecture, there's only half of the student will attend the lecture. So which means by my design, I will only include these 75 students. So here, this new sampling frame will be given by the students that I know they will attend in this lecture. So this probably help you to understand what is the sampling frames talks about here. So after we talk about the population sampling frame and sample, and we know that they kind of have a such kind of hierarchical relationship. So the population is something that we are really trying to learn about, and but sampling frame is this something that we really could learn about. And finally, we just recruit our data by taking part of the or a subset of the individuals in our sampling frame, which is forms our sample. However, in reality, like in our example in 2016, our polling or our sampling results is not always correctly reflect our true results. So as I mentioned in the example of the polling of 2016, we have seen that completely different results for the polling of that year. So one of the important reason is the sampling bias. So this is because the sample that we are trying to take is not really representative to our general populations. So in our scenario, for example, our population is a really diverse population. It has people of different color. We have blue people, orange people, and green people. We have such diverse population. However, sometimes we might choose a subset of the sample, say all of the blue colored individuals being selected. And in this case, this individual or these samples will not be really representative to our general population because we just ignored the opinions from the other groups. So that's part of the reason that we have seen the bias in our sampling results. So in fact, there's different source of the sampling bias. So say in our previous example, although we have a very diverse population, but we end up with individuals only with one group. So there could be two reasons. The first reason is just that we are so unlucky that we just collect those individuals from the same group by chance. And this is usually resulting by the fact that we only have a very small sample size. So for example, if we have this population, and if we only recruit, say, two individuals, and in this case, it's very likely to happen that our final two individual sample will contain the same group, right? So that's if our sample size is small, then that's very easy to happen. So to fix this problem, then what we need to do is to increase our sample size so that we are more likely to incorporate the individuals from the other group so that we can have a more diverse sample group. And another situation is more severe. So this situation is about the design itself. So sometimes, although we are trying to study our entire population, which is given by this blue line, and we know that our population is really diverse. It contains individuals from different groups. However, by our design, we have only include the individuals that for the blue people, for the majority, and only a very small amount of or very minority for the other group. For example, we say the blue people are more likely to have a phone. So in that case, if we do the polling by phone, we will pretty much end up in this sampling scheme. And in this case, this problem is very severe because we have to redesign our sampling design to circumvent the sampling bias, resulting to this discrepancy between our population and the sampling frame. Any question for these two different way of the sampling bias? Okay. So now you have understand what is sampling bias. Then I'm going to take one question from the practice question for today for this week. So in this practice question, what we're trying to do is we're trying to estimate the driving time for the individuals to work. And we collect the data and we present the distribution using this histogram. So in order to estimate their mean time to the work, we are not going to compute the entire mean of the entire population, but instead we are going to sample individuals from this group. And here, when we do sampling, we instead of just do the sampling from the entire population, we'll divide our population into 3 groups. So the first group are the individuals who is between 20 minutes to 40 minutes, and the second group is from 40 minutes to 70 minutes, and the third group is greater than 70 minutes. And we have 9 individuals in the first group, 10 individuals in the second group, and 13 groups in the third group. So the question is, if for these 3 groups, we collect 4 individuals for each group, and we compute the mean of the sampled individuals. The question is, the mean, will it overestimate the mean of the population, or it will underestimate the mean of the population, or it does not has any sampling bias at all? So I'm doing a polling about this. So to think about this question, or to understand how our sampling biases looks like, you can think about how each group is being represented. So for the first group, which is the individual with the small amount of the small driving time, they have 9 individuals, but they have 4 units. So is it underrepresented or it's overrepresented? So you can think it in this way to decide whether it will overestimate or underestimate the mean. So for example, for the first group, we have 9 individuals, right? And we have 4 units. So what's the ratio for that? And for the last group, we have 13 individuals and we only have 4 units. So is that overrepresented or underrepresented? Yeah, I guess the majority of students get it right now. So yeah, the answer is the underestimate the mean, because as we can see that the ratio is 4 to 9. And for the group with the tiny amount of the time to work. And for the individual who spend a lot of time for driving, and there we only take 4 out of 13. So this group is definitely underrepresented, and this is overrepresented. So in this case, our sampled mean will shift or converge to to the mean of this group, because this group is overrepresented, right? So that's the idea of doing this type of question. So again, this type of the discrepancy, or this type of the sampling bias is coming from our second reason, which is we do have a mismatch between the population and our sampling frame, because in our sampling scheme, we take too many individuals from this part, and we didn't take enough individual from this part, and finally we will kind of shift our mean to the towards the mean of this group. So that's why we see some sampling bias for that. So as you can see that for the sampling, the biggest concern is the sampling bias, because either we are not unlucky due to the limited sample size, or because of the mismatch between the population and the sampling frame. So in some scenario, for example, for some very important things we want to know, we won't do sampling, and instead we are going to do the census. So the census is a very is the opposite to the sampling in the sense that sampling is taking the subset of our sampling scheme. But the census, on the other hand, will take all of the individuals out of our sampling scheme. So it will collect the data from the whole populations. But as you can imagine, if we do it in this way, first of all, it's gonna take really long time to do the collection because you have to ask everybody's you have to ask everybody some opinion or their information. And also, there's a one fact that even if we collect the data, it still can create us a lot of long time to process the data we have. For example, in the census in Canada in 2016, although they finished collecting the data in 2016, but the final results is coming 2 years later, which is in the 2018 or even 2019. So it takes a really long time to process the data. And another problem is that we would expect a very long intervals for each attempt for the census. We cannot do census every year because first of all, it takes really long time to process the data. And it also takes a long time to collect the data. And what's even worse is that it is very expensive to collect the data using census. So in Canada, the census is being conducted every 5 years. So that's the fact in collecting the census. Okay, any questions so far? Oh, we have a question for the previous example, I think. So let me see. So what does, so the first question is about what does this 4 units represent? So here, 4 units is the number of the sample that we taken from each group. So for these 9 individuals, we take 4 individuals from this group, right? That's this 4 units talking about. And there's a question about, is it underestimated in this case only or as a general statement? So it is underestimated for this sampling scheme. So if we how to say, if we keep the ratio between different groups, but I think it's impossible for this context. But for example, if we have 9 million and 10 million or 13 million, and we can have, say, we collect 9 individuals from this group, 10 individuals from this group, and 13 individuals from this group. And then our ratio is consistent with the ratio in the general population. And in that case, we wouldn't expect there's any bias. Does that make sense? Okay, there's another question that if the data had a mean of 3, then the sample mean would be overestimated. What do you mean if the data have the mean of 3? So we're comparing the mean of the sample with the mean of the general population. So this mean that we are trying to compare to is the mean of all of the individuals. So that's the target, the population we are trying to compare with. So there's another question about why is the overestimate the mean, not underestimate the mean when 13 is larger than 9? Okay. So I guess the question is why we have a large number here, but we didn't have underestimated the mean. This is because although we have a large group here, but the problem is we didn't recruit the same amount or the same proportion of the sample from this group. So in this case, this group will be underrepresented, right? how do I know is it underrepresented? So this is a very, it's a relative concept. So I mean, comparing to this group, right? We have 9 individuals, but we have 4 units. So basically, we have almost half individuals will represent this group, and this group we have 4 individuals. It's no larger than 1/3, right? So the ratio of representative is smaller than the ratio for the representative in this group. So that's why we say it is underrepresented. Okay, so uh, so let's take a 10 minutes break. And if you have any other question, I'll just stay here for explaining. And we will come back at 2:33. Uh, so, uh, so there's a statement say, if you had 4.1 unit green and 5 unit purple and 6.5 unit red, then there would be no sampling bias. Yes, that's correct. So this is because in this way, the ratio between each group is matching the ratio in our general population. So there's no, like, we are shifting our weights to any of the groups. So there's no bias for that. So to be no bias, you need to have all ratio to be the same. Yes, I think so. You have to make sure all of the ratio for each group to be the same, to exactly match the ratio in the general population. Okay, there's more question. So is it true that ratio and interval data be either discrete or continuous? So in this course, we just treat the ratio and interval data as continuous, and for the nominal and ordinal data to be discrete. So that's our definition in this course. Okay, so let's get continued. So in the previous half of today's lecture, we talked about several important vocabularies that involve in the sampling procedure. And in the second half, we are going to really doing the sampling. So in this part, I'm going to show you different important sampling designs that you could encounter in the statistic literature. So before doing that, I would like to introduce two different ways for obtaining our sample. So in the statistic context, we usually distinguish the sampling with replacement with the sampling without replacement. So what's the difference between these two techniques of obtaining our sample? So imagine we have a hat to collect the information or collect our data. And what we're trying to do, the sampling is like that. We write a note for each number, which represents individual or unit. And we're going to put all of these notes into the hat. And for sampling with replacement, it is like that. So we are drawing one note out of the hat, and we find out, okay, it's one. And then we're going to put this note back to our hat before we drawing another sample. So by that, it means for each sample unit, um, they have unlimited chance to be selected in our sample. So we could end up with our sample like 11932 because it is possible for them to be reselected. However, for the sampling without replacement, it will be different in the sense that after taking our first sample, which is one, we're not going to put it back anymore. So in that case, we will not expect there's uh, any same numbers appear in our sample. So for the for the definition of the sampling without replacement, it's like each sample unit of the population have only one chance to be selected in our final sample. So the example for the sampling with replacement is like we rolling a dice, because for each time rolling a dice, it won't influence your previous results, or it won't influence the future results. So each result will be independent. So in that case, we do expect to obtain the same numbers for each time. And for the sampling without replacement, one thing that come into to my mind is the lotto. So we basically select 6 numbers out of 49 numbers. And for by this selection, we don't expect any two numbers in our sample should be the same. So this is the main difference for these two technique of doing the sampling. And in our sampling context, we usually talk about the second part because, like when you do polling, it does not make sense to dial the phone call to the same individual twice and to ask their or to collect their data twice. So when we do sampling, we usually using this sampling without replacement techniques. So in the following part, I'm going to show you quite a few different sampling scheme. So the first sampling design is, I guess, the most frequently used uh, by the individuals who didn't have the statistical training. So this sampling method is called convenience sampling. So what it says is like we join the part of the population that is close to hand. So which means we only collect the information from the individuals that is convenient to us. For example, say you are trying to collect information about people's opinion about their about which party they support, and then you do a street survey. So you stand in a crossover and ask all of the people passing by about their opinions. So in that case, this sampling is exactly the example for the convenience sampling. So first of all, that's easy and that's simple. Then because you didn't really think about, you didn't to spend time judging who I should ask, and you didn't to spend money to like to buy a hat and draw a number out of the hat. So in that case, it is very convenient. But the problem is that in this way, our results will be very biased. So there's a huge sample bias resulting from this convenient sampling. So for a street survey, uh, the first problem that comes to our mind is that is for the individuals who has the accessibility issue. So, for example, for some individual, they are less likely to walk on the street, and then they probably excluded uh, in your sampling frame directly. So in that case, our sampling results is really problematic. So for this convenience sampling, we didn't use any techniques mathematically to help us to decide who we're going to include in our data set and who we are not going to sample. But in the following sampling designs, we are using several mathematical reasoning to help us to decide who we're going to uh, include it into our sample. So the first or the simplest version of it is called the simple random sampling. So the simple random sampling is like that. Okay, we have 12 individuals in our population right now, and we know that, okay, we have three individuals from three different groups. So we just roll a dice which has 12 facets, say, okay, then we first get, okay, number three. So number three will be included in our sample. And we roll the dice again, and we get number seven. And we roll the dice again, we get number six. And finally, we get number 11. So in this way, you can see that because the dice itself is fair, so the probability or the chance for each individual to be selected in our sample, they should be the same. So the probability of one to be included is the same as the probability of three to be included. So you just keep in mind that's a very important precondition in our simple random sampling. And in the simple random sampling, because we are rolling dice to help us to decide what is our sample composed, so definitely we could end up with different combinations. For example, we can have 1, 2, 3, 4 by chance, right? And we have 9, 10, 11, 12, and or 1, 8, 9, 10. So I would like to emphasize that even this combination 1, 2, 3, 4 seems so nice, and uh, it's uh, it's so organized. I mean, for the order of the numbers, but the probability of we get each combination is in fact the same. So that's the most important precondition for the simple random sampling. That is the probability for so for each possible group of a chosen size from the population has the exactly same chance of being selected. And if that is not satisfied, then it is not a simple random sampling. So keep in mind that this is very important. So for the simple random sampling, I mean, the dice is fair because we didn't have our own judgment upon the individuals who we are going to recruit it in our sample. But we do still have problem. Like sometimes we just unlucky to recruit a combination like this, which is 1, 8, 9, 10, where all of them belongs to our blue group. So in fact, we didn't do it purposely, but we just so unlucky to end up with this combination. So this is actually one problem for simple random sampling. So to fix that problem, there's a more complicated sampling framework called stratified sampling. So for the stratified sampling, it contains a two-step procedure. Okay. Okay, so now I see a question, so I'm going to answer the question first. So wouldn't it not be like rolling a dice, because rolling two dices, there's different probability for each number. Yeah, maybe dice is not a good example, because dice is for, like I said before, the dice is for the sampling with replacement. Actually here, maybe I should use the lotto as the example, because that's the sampling without replacement. Yeah, that's a very good catch. Yeah, maybe I shouldn't use the dice as the example. Yeah, you can think about we draw a note from the lotto, right? So that's how we draw this sample. So there's a question asking, what is the issue with the simple random sampling? So the issue with the simple random sampling that, because remember, we're always trying to circumvent or avoid the sampling bias that we discussed in the first half of the class. So for example, for this combination, so we have the same probability to obtain that with the all other combinations. And for this combination, we have all individuals from the same group. So which means the individual from the orange group will not be represented. And the individual from the green group, they won't be represented as well. So in that case, we will feel very unsatisfied about our sample, because that might cause the problem of the sampling bias. And this is not resulting by our purpose. We didn't do it purposely, but sometimes it's possible for us to be so unlucky to end up with that cohort. So yeah, yeah, thank you for helping me to answer that. So yeah, basically each combinations have the same probability to be our sample, but still for these combinations, some group will be underrepresented because there's no enough sample from the other groups, right? So I guess you have to distinguish the concepts for the probability for each individual to be included, and the ratio for those individuals in our final sample. These are completely two different things, right? So even if each individual, they can be appear in our final sample, but still we could end up with very unlucky combinations that our our resulting sample is not so informative for other groups. So that's the main issue for the simple random sampling. So to fix that issue, we propose this stratified sampling. So stratified sampling, we're going to do a two-step procedure. In the first step, we're going to group all of our individuals according to the color group they are in, because we know the color matters in their opinions to which party they support. So the first step, we create each group for each color of the individual, and we called each group as stratum. So the stratum is we have this is a stratum, and this is a stratum, and this is also a stratum, and there's a plural form for this word, which is strata. So in this scenario, we have three strata. So this is our first step, which is stratify our population by the color. And then we are going to do the same thing as we did in the simple random sampling. We are going to draw a lotto from these 6 individual, and we happen to get 9. And similarly, we get 4 from our second group, and our 7 from the last group. So in this way, our final sample is composed by 9, 4, 7, which is coming from the completely different groups. And in this sample, it contains all of we are sure that we will include at least one individual for all of the groups. So that's the advantage of doing this stratified sampling. But of course, we didn't have to make it like that, only drawing one individual from each stratum. For example, we can draw 2 individuals from the first stratum because we have a large population in the first stratum. right? So to be fair, we should draw two individuals to serve as the representative for this group. So in that case, the beneficial here is just to make sure that we always have the individuals from the diverse group. Any question for stratified sampling? Okay, so now let's do an exercise. So now you understand what is the stratified sampling doing, which is basically contain the two-step procedure by firstly stratify our population into three groups and then sample our individual for each stratum. So the question is, based on the definition of the stratified sampling and the definition of the simple random sampling. So if we get a sample, say 947, can we regard it as the same way we get from the simple random sampling? Which means, can we say that this 947 could be drawn from our simple random sampling if we draw it in this way? So to answer this question, you need to think about what's the definition of the simple random sampling, right? So when we talk about the simple random sampling, the most important thing that we need to keep in mind is that for all of the combination, for each combination of the sample, the probability we draw them should be the same. So does that satisfy here? Does that satisfy in this stratified sampling? Oh, the polling is end, sorry. So so just now we got majority answered no, right? Okay, so the answer is actually no. Why? So let's come back to the definition of the simple random sampling. The simple random sampling is saying that the probability of drawing 947 is the same as the probability we draw from all other random three group. So for example, it's the same as the 347. That is the same because we draw a 1 from 3, 1 from 4, and 1 from 7. That's the same. But the problem is, can we draw like 136, which is here? For stratified sampling design, we can't draw this group 136 because they are coming from the same cluster. And that violates our definition in a simple random sampling in a sense that the probability we draw from 136 is different from the probability we draw with 947. So that's why for the sample collecting from the stratified sampling, it is not a sample collecting from a simple random sampling. Okay, so now any question about this question? Do you need any more justification or explanation for that? Okay, great. So now we see a type of more complicated version of the sampling scheme. And in fact, there is another type of the sampling scheme, which is actually going to the opposite extreme. So which is called the cluster sampling. So similar to the stratified sampling, for the cluster sampling, the first thing we do is we are trying to group those individuals according to the population, according to the color group they are in. So we end up with three different groups. But for the cluster sampling, we are no longer called as stratum, but instead we are called it clusters. So right now we have three different clusters. And instead of just collecting one individual each in each of these stratum, we directly pick the entire cluster by randomly select from these three clusters. So for example, we roll a dice which has three facets, and then we end up with three. Then we'll we will recruit this group, this entire group into our sample. So in this way, by using the cluster sampling, our sampling results will contain the entire group of it. And of course, sometimes we could draw two groups. For example, we will have 2, 7, 12 and 4, 5, 11, which is the combinations of these two groups. So the cluster sampling is basically we divide our groups, we divide our population according to the colors, and then the complete subset of the cluster will be included. And here we define it as census. So remember, for when we do a census, we include all of the individuals in the populations. So any question for the clustering sampling? Okay, let's do another iClicker question. So right now, we have our exemplary population, and we know that they are grouped into these three different clusters. And so for these three different sample, which sample are possible to collect from the cluster sampling based on the example I showed you earlier? So remember, the cluster sampling needs to include the entire group. So that's the key for this one. Okay. Okay, so I get majority in choosing A. So A is choosing 1, 3, and 6, right? So, well, all of these individuals are coming from the same group, but the problem is that that is not the entire group. So remember when we discussed the clustering, we are talking about when we draw our sample, what we are drawing is not the single individuals from from each cluster, but instead we are drawing the whole cluster altogether. So in fact, this 136 cannot be our cluster sampling because that's just part of our first cluster. And also 142 cannot be because that is more like a stratified sampling rather than the cluster sampling. And for C, we have 2, 4, 5, 7, 11, 12, which is exactly these complete clusters of these two groups. So that's why we say this sample is coming from the cluster sampling. So I guess the take-home message here is just to keep in mind that for the cluster sampling, we are trying to, the basic unit here is the cluster, not just the individual. So every time when we do the sampling, we are sampling the whole unit, the whole clusters rather than an individual. And one example for the clustering is in the study of the bacteria. So, so in our data set, we have a lot of colony, right? And each colony contains a lot of bacteria. So what we are trying to do is we are trying to sample what's the compositions of those bacteria in each clusters. So since each clusters, the composition are pretty much the same. So that's why instead of just choosing each single bacteria, because that is really hard to sample, right? We have millions or billions of the bacteria here. So instead of doing that, we are trying to sample the cluster together. So in this way, we have so many clusters, and we randomly select 3 clusters out of those clusters. And based on these 3 clusters, we can determine what's the compositions of different bacteria. So the most important thing for the bacteria example is that the compositions for each clusters are similar. So in this case, the cluster sampling is very suitable. So from our original case, for this case, I would say the cluster sampling is not so suitable because for each cluster that we define, it's so different because they are in a completely different color. So in this way, we will end up with the completely biased sampling results. So for cluster, it's not suitable for this case. But if we have, say, our clusters, each cluster is mixture with different colors, and then probably for that case, it will be very suitable for the cluster sampling. So in that case, when we define our clusters, it will probably based on the different characteristic. For example, we can based on the gender. So we have um, two different class, and for each cluster, we have a pretty much mixed color of the individuals. So in that case, it is more suitable for the cluster sampling. So right now we have seen like what's the different techniques of using the sampling techniques to get our sample. But so far we have learned the simple random sampling, the stratified sampling, and the cluster sampling. So these three sampling procedures can help us to get the sample, but they have the problem that we have to generate a lot of random number or random variable. For example, for the simple random sampling, if we say our population is not just 12, but instead is 12 million, then we want to sample 4 million people out of this 12 million individuals. And in that case, you can imagine it is really hard to generate so many random variables. So in that case, the simple random sampling will not be suitable for this type of the study because sampling random variable could be very expensive because we definitely cannot roll the dice for so many times. So there's another way to solve that problem, which is called the systematic sampling. So for the systematic sampling, it's like instead of directly sample our individual out of these 12 individuals, we are trying to just look at the first couple of them. So we are trying to select one representative from this first three individuals. So for example, we first select two, and then the remaining individuals will be automatically determined based on the results of uh, our starting point. So one way to determine how we automatically get the sampling is to determine the individuals by a constant interval. For example, here we can consider the interval to be exactly 3. So if our interval is the 3, then we start with the first 3 individuals, and we roll a dice, and we get, okay, the first one is 2, and then we just count what is the individual for every 3 interval. So 1, 2, 3, we get 5, and 1, 2, 3, we get 8, and 1, 2, 3, we get 11. So that's how we get the sample from the entire population. So the benefit of doing this way is that in this scenario, we only generate the random variable once instead of generate those random variable 4 times in a simple random sampling. And of course, if we get the result to be 1, then the remaining will be 4, 7, and the 10. So there's a question like, is every if the interval is 3, shouldn't we get number shouldn't be 6 then 9? Okay, uh, this is this is because our starting point. So our starting point here is, so our starting point, first of all, I would say that our starting point is random, right? So we are drawing one starting point out of these 3 different possible starting points. And because we draw number 2, so we will take 2 as our starting point. And for 2, we will start with 2 and count 3. So 1, 2, 3, we count 3 is 5. So you said 6 and 9, that is actually belongs to the starting point of the number 3. So if we roll a dice of 3 facets and we get number 3, then we will get 3, 6, 9, and 12. So that's how we systematically obtain our sampling. So the randomness is for this systematic sampling is coming from the randomness we selecting our starting point, right? So in our simple random sampling, we need to write a notes for 12 individuals and put them into our hat to draw our sample, right? But for the systematic sampling, we just include the first 3. We just write the note for 1, 2, 3 and put them into hat, and we just draw the random variable just once. So that's the benefit of doing the systematic sampling. Okay. So as you can imagine, for the for the systematic sampling, the one very important thing is that the order of this population is really matter. So if we purposely put every 3 individuals to be the same color, like 1, 4, 8, 11 to be the same color, then no matter what first starting point we obtain, we will end up with the individuals with the same color. So that's not what we want. So for the systematic sampling, although it saves us in a sense that we only need to draw random variable once, but we need to make sure that our population need to be well shuffled in a sense that there is no systematic pattern in the order of those individuals. So that is very important for the systematic sampling. And also another challenging for the systematic sampling is that it involves a lot of math, right? So like right now, we in order to draw in order to draw 4 individuals, we have to select our interval to be 3. The question is, how do we decide this interval k? So in fact, to determine this interval value, we can entirely base on the 2 information. The first information is the size of our sampling frame, which is 12 over here, and we usually denote it as the capital N. And the second information is what is our desired sample size. And right now, what we want is just 4 individuals. So we use the small n to denote that, which is number 4. So the interval k is entirely depends on the ratio between the sampling frame size to the desired sample size. So here it will be 12 over 4, which is exactly 3. And for sometimes, as you can imagine, for example, sometimes say I want to draw 5 samples out of these 12 individuals. How could I select the individual? How could I select the intervals? And in that case, the interval k should be n divided by small n, which is 12 divided by 5. In that case, it is not an integer, right? So for that scenario, we usually round that integer, that number to the closest integer to that number. So for that case, we cannot guarantee that we will get the desired sample size, but the difference is probably just 1 or 0. So in fact, that doesn't matter. The rounding issue doesn't matter here. Any question for the systematic sampling? And also any question for deciding the intervals? So the take-home message here is just that when we calculate the intervals, we just take the ratio of these two. And if it's not an integer, we just round it to the nearest integer because that's not really matter that much, because the only difference of our final desired sample size is just 1 or even 0. So the question, are we going to calculate on the text, midterm, and exam? No, we're going to calculate that. So this is just showing you how we do the interval. But you are not required to calculate that in the exam. So I guess for today's lecture, you guys probably feel pretty easy because there's not much mathematical involved. And as you will see in the practice question, mostly the question for today's lecture will be about your understanding of the different concepts. Like if I give you a sampling procedure and you tell me what kind of sampling scheme this procedure belongs to. And also, if I show you a scenario, what is the concept, what's the population, and what is the sample, what is the non-responder, and something like that. So it's more like a conceptual questions rather than mathematical questions for today's lecture. Okay, so far, we have discussed 5 different sampling schemes: the convenient sampling, the simple random sampling, stratified sampling, the cluster sampling, and the systematic sampling. So we usually don't really consider convenient sampling as the sampling in statistics. So for statistics, we only talk about the remaining 4 different type of the sampling. And so far, these 4 different type of the sampling is the most basic sampling framework. And you can say almost for every sampling in the real life, they will involve these 4 different sampling. But in the real life, the things is not as simple as this, because we have a lot of concern, like we have funding issue, and we have difference for different groups. For example, if we sample people's opinion for the government in Canada, your sample taken in Alberta and for your sample taken in Quebec will be definitely different, right? So there's a lot of concern about this. So basically, for a lot of times, our original basic sampling scheme doesn't work that well. So in that case, we have to consider an even more fancier sampling scheme. And and right now, this type of the sampling scheme is called the multi-stage, which is exactly the combinations of multiple sampling framework together. So as you can imagine, for this multi-stage sampling scheme, it could be really sophisticated because we have a lot of stages. And our final results also involves a very complex mathematical computation. So one example of this multi-stage sampling is the combination of the cluster sampling and the simple random sampling. So remember, for the cluster sampling, we first group our individual into different cluster, right? So you can imagine, okay, we want to study people's opinions in Canada. So we consider each province as a cluster. So the blue is the Ontario, green is the Alberta, and orange is the, say, Quebec. So in that case, before I sample my individuals, because I have a funding problem, I cannot take the airplane everywhere to collect the information from the single individual all around the Canada. So instead of directly sample the individual, I firstly sample the province. So say, okay, I sampled the Quebec here, and then based on the province I sampled, then I'm going to sample individuals that is within that province. So in this case, this sampling scheme is a 2-stage sampling. The first stage is using what we learned in the cluster sampling, and the second stage is exactly the simple random sampling. So basically that's what we did for a multi-stage sampling, and that is a very typical sampling framework in the real life. But in the exam or in the quiz, I won't require you to understand the multi-stage sampling. I just put it here to let you aware that we have a lot more fancier sampling schemes. Okay, so that's pretty much the material for today. And to ease your workload for today, we don't have any independent tasks. So which means we don't have the video or reading materials for you to study independently. And we also don't have any follow-up quiz for those independent tasks. And just remember that our midterm is taking place at October 8th, and have a nice Thanksgiving. Okay, so right now this is the end of the course, and you just feel free to leave, and I will see you the next week. And I'm going to stay here to answer the question. Okay. Okay. So for the midterm, for those that the Word documents and OneNotes, can we have that open? Because I think these two is quite new to me in a sense that I'm not pretty sure it works well in a Proctor track. Um, I do heard of the concern that the Proctor track could prevent you opening the OneNote or uh, online if it is online. So probably if you during your onboarding test you can open it, then I think that's fine. But for me, I'm completely fine with that. Yeah. So other than practice question, do you recommend any other ways to prepare? If you're just preparing for the midterm, I think the practice question will be enough. And also, you need to also be uh, go over the question, especially the iClicker question we go over during the class. These questions are also very important. Are there practice exams available? Uh, I won't post any practice exam because for the practice question, they are actually coming from the previous exam. So I think that's uh, very representative. But also, I would like to mention that for our midterm one, the wording of the questions will not be that long as it appeared in the practice question. It probably just 1 to 2 sentences for each question. So you won't spend too much time on reading the question itself, like you did in the practice question probably. So are the midterm question in the exact same format as the practice question? Yeah, so the format is exactly the same. So it's the multiple choice and or the fill in the blank question. And it's not that long as in the practice question because I don't want you to spend too much time in reading the question itself. Um, are you available for office hour later today or tomorrow prior to the meeting? So I do have an extra office hour in the Wednesday morning. So if you want to contact with me, you just book an appointment in the booking system, which is in the first page of our website. Uh, okay, there's a question about 2 ways of obtaining sample. Okay, so I believe it's okay. It's here. So if we use our notes or Proctor track, we'll get a flag. Uh, I'm not pretty sure about this, but if you get flagged just because you opened your note, I would say it's completely fine because I will review all of the flags that appeared in the system. Yeah. How many questions? We have 20 questions in a midterm. Uh, do I still have? Oh, I didn't know Monday is the Thanksgiving. Thanks for letting me know. But I think for now, I could have it for now. But if there's any changing, I will notice you in advance. Question 3 again. Are you referring to the This question 3. Sorry, what do you mean at question 3? Oh, underestimating the mean. Okay. Oh, I just have so many. Okay. Okay, it's this one. So for this question, if you want, so what we are trying to compare is what's the mean calculate based on the sample that we draw and the mean of the general population, right? So if you look at the general population, we have a lot of individuals that has a large driving time to work and very relatively smaller individuals from the tiny driving time, right? But if you look at our sample, we equally drawing the same amount of the individuals for each different group. So by that means, uh, these 4 individuals will overrepresented our general population. Does that make sense? Because we only have 9 individuals in the population, but we choose 4 of them. So when we calculate the mean, when we take the average, we actually put in more weights for this group. And for this group, they have a smaller time to drive to the work. So we are basically putting more weights to the small time. So that's why we underestimate. So which means the mean for our sample is smaller than the mean for the general population, right? That's why we uh, underestimate the mean of our sample. Oh, sorry, underestimate the mean of the population by using our sample, right? So there's a question asking what is the, okay, so trying to explain more about cluster sampling. Okay, so for cluster sampling, you can imagine it as the opposite sampling frame from the stratified sampling. So for stratified sampling, we include, so the same thing for these 2 sampling schemes is that both of them group our individuals according to their color, right? But the difference is that the stratified sampling will only include 1 individual for each group. But for cluster sampling, we're going to recruit the entire group or entire cluster for each cluster. So that's the different things. So for the results, we will expect that for the resulting sample, we could end up with the complete clusters. But for the result of the stratified sampling, we usually end up with the combinations of the different clusters. So when is the multi-stage sampling best used? Like when is the most relevant to use? So multi-stage sampling is uh, um, is most suitable for a large project. Like say I want to collect information, say for like in my example, like I want to survey in the entire Canada population, and but I also have the limited funding, so that's why I combine it for the clustered and the simple random sampling. So we incorporate the cluster because we want to concentrate on part of the province so that we don't need to travel all around the Canada. So that's the idea of the multi-stage sampling. So the multi-stage sampling has a lot of combination. This is just one exemplary combinations for that. There's definitely other combinations. So for this combination, we have reasoning like this, but for some other combinations, like we combine the stratify and simple random sampling, then that's a different, that's in a different need. So it's mostly a case by case scenario. Okay, so I guess that's pretty much for today. So thank you again for attending to, oh, you have a personal question. Maybe you can send me a message, send me a message on, oh. Is it also case by case to determine if simple random sampling and stratified sampling is better? Yeah, so mostly for this, so the reason we're choosing stratified sampling rather than the simple random sampling is that we want to have a more diverse a subset of the sample. So that's the reasoning of this stratified sampling. But as you can imagine, for stratified sampling, we need to take more time to group those individuals into different strata, right? And also, it takes a lot more money for that. So that's the problem for. So they both have pros and cons. So it's really depends on the case, the scenario that you are talking about. Like in my project, for example, I have a very limited money, and I but I don't care about the diversity of the sample size. Then the simple random sampling is better than the stratified sampling. Okay, so I guess that's pretty much today. So I'll see you guys next week. Bye, everyone.